In modern warfare, there is a saying, you never hear the bullet that kills you. But in the world of aviation noise, is death? A standard fighter jet engine produces 140 decibels of sound. It is a scream that tears through the sky, announcing your arrival to enemies 50 miles away. But imagine a machine, massive, heavy, lethal, that can fly directly over your head and whisper. The B-2 Spirit stealth bomber. $2 billion per unit. It is invisible to radar, but more importantly, it is invisible to the ear. Engineers spent decades trying to silence aircraft. They failed. Turbulence seemed impossible to kill until they looked up into the night sky and found a killer that has been operating in total silence for 60 million years. This is the story of how the deadliest aircraft in history learned its greatest trick from a barn owl. Meet the barn owl. Unlike the falcon, which relies on speed, or the eagle, which relies on brute power, the owl relies on stealth. Scientists conducted a famous experiment. They placed high-sensitivity microphones in a sealed room. First, they released a pigeon. Every wing beat was a drum. The turbulence was chaotic. The prey would hear this instantly. Then, they released the owl. Nothing. The audiometer remained flat. The owl glided past the sensors like a ghost. This shouldn't be possible. Physics dictates that a wing moving through air must create turbulence. Turbulence creates pressure waves. Pressure waves create noise. So how does the owl cheat physics? How does it delete its own sound? The secret is in the feathers. Most birds have wings with clean, sharp, straight, trailing edges. When air flows over a sharp edge, it falls off the back in large, chaotic vortices. It's like water crashing over a cliff. That crash is the noise you hear. But look closely at the leading edge of an owl's primary feathers. It is not straight. It has tiny, comb-like serrations. Biologists call them fimbriae, visual, green smoke flowing through the serrations smoothly. These serrations act like a vortex generator. They break up the large block of air into hundreds of tiny, manageable streams. Instead of a loud crash, you get 1,000 tiny whispers. The air is smoothed out. The turbulence is killed before it can become noise. But nature added a second layer. The rest of the wing is covered in a velvety, down a soft, fuzzy texture. This velvet absorbs high-frequency sounds, dampening the noise of the feathers rubbing against each other. It is a natural acoustic camouflage suit. When Northrop Grumman was designing the B-2 Spirit, they had a problem. They solved radar invisibility with geometry, but acoustic invisibility? Engineers studied the owl. They realized that to reduce the acoustic signature they had, to manage the airflow, at the trailing edge of the wing. While the B-2 doesn't have feathers, the principles of turbulence disruption were applied to its aerodynamic profile. They designed the airframe to be one continuous wing, eliminating the sharp angles and tail fins that create loud drag. But the most direct application of the owl's patent isn't just in war. It's in your backyard. Wind turbines. One of the biggest complaints about green energy is the swoosh, swoosh noise of the giant blades. It disturbs residents. It limits where we can build. Engineers at Siemens and GE took a macro photograph of an owl's wing. They created a serrated comb attachment for the trailing edge of their turbine blades. They literally called it the owl's wing add-on. The results were instant. Just like the bird, the machine went silent. The serrated blades reduced noise emissions by several decibels. This sounds small, but in acoustics, it is massive. This silence allowed turbines to spin faster. Faster spin means more electricity generated. It meant turbines could be built closer to cities without complaints. The owl didn't just teach us how to hide. It taught us how to power our homes more efficiently. Let's talk numbers. In the military, the cry of silence is survival. A B-2 bomber costs $2 billion. If it is detected, it is destroyed. The biomimetic stealth features protect that asset. In the energy sector, the why is even clearer. Wind farms equipped with owl wing technology see increased energy output simply because they are not restricted by noise regulations. A 10% increase in efficiency across a massive wind farm equals millions of dollars in extra revenue over the lifespan of the turbines. Silence is profitable. Biomimicry is not just cool science. It is a competitive business advantage. We live in a loud world. We associate power with noise. A loud engine, a loud explosion, a loud speech. But nature teaches us a different lesson. True power is silent. Efficiency is silent. The owl doesn't need to roar to prove it's the apex predator. It dominates the night because it has mastered the air itself. It moves through the world without disturbing it. As we build the future from silent electric air taxis to stealthier defense systems, we are finally learning the value of quiet. Maybe the most advanced civilization isn't the one that makes the most noise, but the one you never hear coming. Nature's library has 60 patents. We have only read 2. Next episode, why does a shark's skin feel like sandpaper? And how is it keeping hospitals bacteria-free? Nature's patent number 3. Visual subscribe button. I'm Carl. This is Nature's patent. If you value silence and science, subscribe now. Remember, nature invented it first.